Hi, I'm Riccardo Pelizzi. This is the presentation for my internship project, cross-site scripting protection for Firefox. So XSS attacks, which is cross-site scripting attacks that we are trying to stop, are a type of web application vulnerability that allows an attacker to inject JavaScript code into a vulnerable page and circumvent or bypass the same origin policy on the victim browser where the attack actually happens. And the JavaScript code is injected because the attacker can break the assumption that some web application have that whatever resource they embed into the page as text is not text, but can be HTML code. And this HTML code can be a script node that then gets executed on the page. And the problem, why the attack is damaging, because we break the same origin policy. The code is served together with the rest of the response from the page, and this means that it has access to the resources, to the confidential resources that are only normally accessed to the page. So normally, only data served from Google.com can access cookies from Google.com. But now Google.com will embed some code that has been created by the attacker, and maybe it's even hosted on attacker.com, and we just break the basic policy that guarantees confidentiality on all websites. This is the flow of the attack in case of a reflected access vulnerability, which is what we are focusing on for this filter. And the attacker gets the user to visit a web page, and the response that comes back from the server contains the code itself. And the code is embedded into the page, and HTML has no provenance information. So the browser is not able to tell that the code was not provided by the server. And so it will execute as it was provided by the server, except that it was written by the attacker. This is the architecture of the filter that we have. So basically, we interpose on calls to the JavaScript engine. So whenever the HTML parser or the JavaScript engine itself decides that something needs to be executed, the filter steps in, and we check whether that particular piece of JavaScript code should be executed or not, whether this represents an XSS attack or not. And if it doesn't, then we can drop it and simply avoid sending it to the JavaScript engine, and we can display a notification. We just need two very simple policies. The policies for inline content, so for scripts that are specified together directly in the page, we just try to find the script contents in a substring of the URL in one of the query parameters. The external policy instead is for example, the script tag with the source attribute whenever you embed a URL into the page. In this case, it's very similar. Again, we try to find the script URL in a substring of the URL, but in this case, we can whitelist certain kind of URLs. For example, same origin resources. And the way we do this matching, the way we find these strings into substrings, is using taint inference. You can think of it as a black box alternative to taint tracking, which is a very popular technique to establish the provenance of data inside applications. But mostly you need the source code, and you need to instrument the web application to track the origin of certain data, so that then when it gets used for sensitive procedures, a policy can specify whether it's safe that a user or an untrusted entity provided this data. We can't do that here because we don't have the access to the web application code. The only thing we see is the inputs and the outputs, right? We see a GET request, and we see an HTTP response. And this is what we can use to infer the actual provenance of text inside an HTML page. So if we use an approximate string matching algorithm, we are able to infer whether a piece of text in the page came actually from the get parameters or from the post parameters instead of specified by the web application. And this works reliably if the web application does not transform its values. If the input values that then gets displayed on the page are similar, the taint inference procedure can infer that actually they came that the content came from untrusted source, which is the URL most of the time. The results, this has not landed in Firefox yet, but we already tested it, and it needs more testing, but the testing so far are encouraging. We used it. I used it for a week, and I haven't triggered any policy violations on benign websites, which is one of the goals, of course, is that we have 0 policy violations. We don't want to disrupt the user experience on any website. We tested the filter against 400 attacks, the real-world attacks that have been fetched from a website that contains a repository of real attacks, and we were able to stop most of them, which is good. And the performance is negligible whenever you factor in the network load time, which is also one of the goals, of course. And I'm going to show you a quick demo. Okay, this is a store, very simple store, and we provide our name, and the store says hello to us, welcome actually. And an XSS attack would inject instead a script instead of the name. And in this case, we don't let the script to run because the XSS filter is able to detect that this alert 1, this call, is actually found in the URL. And the filter also supports block mode, which can be activated both by the user and by the server to a HTTP header, which says that whenever a violation happens, the whole page is blocked. So in this case, instead of blocking one script, we block the whole page and we display an error. And this is it. Thanks for watching.